the microphones aren't muted on the close.
Quite literally can't even hear them.
Carrie Ann, I do need a battery.
The microphones don't mute on the
copy.
close. You can't talk until like now. Until the After Dark segment starts. All of that gets picked up and I can't edit it out.
Thanks. Well, I mean, I was quiet, so.
No, you spoke right over the close. Right over the. Roll the close again.
What?
Roll it again. If you can.
To be fair, I can't hear it.
And then you started talking right here. Right here. Yeah, it was you. It was both of you.
Got it.
It was both of you. So now, we get to watch this whole thing again. For Pete's sake.
I blew it.
Ben's production drama.
I did it. I couldn't hear it.
Oh my God.
I feel like you've yelled at me a lot this week for like things that are not my fault. Sincerely though, we don't have a whole lot of After Dark time.
No, but we got a good 15 minutes.
All right. You think you're gonna end this one in 15 minutes, huh?
Whatever this shuttle thing is about. I didn't see the comment.
Oh,
Yeah,
Space
so-
Mike, let me read it to you. Are you ready?
No, let me read it to you.
yeah.
That's
Oh,
my
yeah,
job. I am Capcom here.
I have one job on this ship.
It is to. Yeah, what is it? What's the line?
It's like to repeat what the computer says. I know it's stupid, but it's my only role. Something like that.
Sigourney Weaver. Oh, amazing. So amazing. Galaxy Quest. If you haven't seen it, really seriously go see it. This comment comes from our chat room from one Space Danger. Space Shuttle worked for crew transport to space station, but was permanently canceled politically. Crew transport is now dependent on Soyuz and is so expensive it challenges shuttle. Commercial crew transport is not to be demonstrated.
Oh my God. So where do we begin with this?
That's what I said.
Let's see here.
15 minutes, you think
so
you're gonna get
Space
the-
Shuttle
okay.
mostly worked, other than it not working very well and being obscenely expensive. You need to understand the point of shuttle. What it was originally designed for was not to just go up and back from a space station. It was designed to create a low Earth orbit transit system that we could then use to send to a Mars transit system, and then have another shuttle that goes from that transit system back down to Mars. Did that work? Did that ever come to fruition? The answer is no. And let's remember, that is the original plan behind shuttle. And then, okay. So we canceled space station when we first designed shuttle, and then we radically changed the design of shuttle because the Department of Defense wants way the hell more cargo. But we still, for some reason, unbeknownst to pretty much everyone, have to have astronauts on board to deploy this cargo, which is weird and dumb. And in fact, in the Augustine Commission, I think it was, they basically said, that's weird and dumb and you shouldn't do that. Which doesn't mean you need a totally different rocket, it just means you need the ability to deploy the payload without having to have humans on board. But that's not how NASA interpreted that, so they came up with two whole new rockets, Ares 1 and Ares 5, both of which were a terrible idea, but we're talking shuttle right now. So shuttle also was not canceled just politically. There was some politics there, but let's keep in mind, it was canceled by the Republican administration. It was canceled by a Republican, and then the Democratic administration also said, yeah, no, we're going to keep this thing canceled still. And then we kept it canceled. So both, whether you're Democrat or Republican, your president canceled the shuttle. That's how that actually works. Okay. Yep. Expensive. Let's talk about that for a minute. What are we up to? $80 million per seat? Something. It is ridiculous.
$76 million per seat. However, the construction cost that Russia actually has to pay for this is anywhere between $45 to $56 million, depending on which version of the Soyuz. So we're still talking about something that is less than 10%. Less than 10% the cost of a shuttle flight.
Which, by the way, was approximately $1.5 billion. Now, that is the price of the shuttle. If you take STS-1, all 135 missions and divide it by the 200 and something billion dollars the program took, that's not fair because you generally don't include the cost of the vehicle itself. So let me just, I don't think I have a...
Did they not do like the ground support?
See here. Let's see here. It's let's see. Yep. So it's actually, believe it or not, if you take the price of the mission itself, not including any of the ground, anything else, just the price of what NASA would charge for a commercial mission, it's actually approximately the same price as a Soyuz launch, all of which is more expensive than a commercial flight that are coming soon. And the point of none of them have flown yet, that's somewhat fair. Commercial providers have not flown humans to the International Space Station yet, but we are like right up on it, right? I mean, it's coming stupid fast. So, yeah, the space shuttle didn't work for its original intention. It cost an obscene amount of money. It wasn't reusable. It was refurbishable, mind you, right? You had to basically tear the whole freaking thing apart.
That's why I always say we learned how not to do it.
We learned how not to do it. It wasn't prematurely canceled. Keep in mind, each shuttle was only supposed to fly for, what was it, 5 years? 10 years? It had a shelf life of like 10 years?
100 flights.
What?
So
well,
per airframe.
Yeah,
so.
but they never. Right. Yeah. So there were two metrics. There was the number of flights, but then there was also the shelf life of the orbiter itself. And the shelf life is what. So the per flight we never made it to. Also, we never got to the. How many flights were we supposed to have per year?
It was supposed to be up to I think it was 100 per year.
100 per year. Yeah, we never got even remotely close to that. But in almost every metric, the space shuttle failed. It was incredibly dangerous to fly on. It was insanely expensive. It was refurbishable, not reusable. It got us stuck in low Earth orbit for 30 years. It was beautiful. It was a masterpiece to watch fly. It was incredible to watch in person. I loved watching the space shuttle fly in person. But if we had continued with the Saturn V program instead of the shuttle, imagine where humanity would be right now. Just, by the way, Saturn V, less expensive.
So, yes.
Less expensive.
All right, there's the end of my rant.
Back to Soyuz for a second. Shuttle flew 135 times. Soyuz has flown over 1,700 times, and all of those flights are still less than the entire shuttle program combined over a 50-year period. So don't even knock on Soyuz like that, man. We're just playing.
There you go. That's where yeah.
Don't you talk about my Soyuz like that?
So I know that we've got space pods, but I'm actually going to, because of science, I'm going to yet again just pause them and just shove them to neither one is time critical. Is that correct?
Yeah.
Right.
Also,
You've crashed. Cool.
Yeah.
We're canceling space pods. Is that all right, Mike?
That's fine.
Cool.
That's
I'm
fine.
not gonna say no.
I didn't.
Cool.
I produced media for it, but didn't have it in the rundown before you're cut off anyway. So.
All right. So yep, space pods are dead. Yep. There you go. That's the whole thing with shuttle. Actually, Lisa, what's interesting is you can call in while Mike is attached to the system. I don't know if you knew that. It's a pretty neat new feature we have. And what's really cool is whenever each one of you is talking, it will automatically switch, I think, to the person who is talking. Zapfan! Whew.
One thing I will give Space Danger, though, is he's right at the very tail end of his comment where he said that commercial crew transport has not been demonstrated.
I did give him. I gave him that point. I gave him.
It's like right there.
Yeah. Yep. I don't even know if Space Danger is still here. Wait, hang on. Because that came off of YouTube, right? So I can't see the list from.
Got us all riled up.
No, yeah.
Get our
Well, Space
answer.
Danger came out of our own chat room, so that looks about right if you think about it.
Oh, there's a way to. Hey, Dada, is there a way for? I think there's a way.
Wait, I don't have earphones in yet.
Ooh, I hear.
Oh, I
There we
think.
go. I see it.
Yeah.
Oh, wait, no.
There we go. Yeah, that's Lisa.
I need to make up stuff.
Yes, right? Like, so the two of them.
Did you call me?
Yeah. Can you? I think there's a button you can press to make either Mike or Lisa go full screen on the thing, on the iPad. I think you can like pin a user.
I'm gonna take my mic off.
That's fine. You're
Or
done.
is it just it doesn't auto do? No, it doesn't auto do it.
No, there is a way. There's a way to make it full screen.
I can hear you guys.
It's only so
Okay.
Cool. Now, Mike, you talk for a second.
All right, so
no, that wasn't it. All right.
Doesn't do it automatically.
That's all right. There's a way to make it go. I don't know what it is.
And now I'm talking something. Woo! Words and stuff. And
Well, I mean, it's highlighting you. Yeah. You have way too much energy.
Something.
Do we have the rest of the science crew here? Do we have any of the science crew here?
Yes.
We have.
I
Sarah?
see someone. I see
Oh yeah. Do we have everyone?
Oh my goodness.
No, we're missing Jade.
Oh my goodness.
We're missing Jade.
Yeah, I'm a little more nervous. I'm a little more nervous now.
All right.
Is that cool?
So on that note, because I'm the only one left here, we're going to.
Praise my TV.
Yeah. I thought you were going to turn it upside down.
It was back to front. It's like in reality, it's back to front right now, but somehow something it gets flipped in the camera. So this is like the wrong way around to me. But it's the right way.
It's in your Zoom account settings. It automatically sets it to a mirror image.
Oh, what?
Yeah. So if you go into
that can't be right
go to
because your
home
shirt
and
is
go to
forward.
Settings.
Wait, hang on, hold.
No, my
Lisa,
shirt's
your
not
shirt
forward.
is forward, but the graphic behind you is backwards.
Wait, what?
I need to look.
But it looks.
Can you full screen her again? Because I can't tell with the shirt.
Because to me, what I'm sending to you looks. Okay, what the hell?
All right,
Okay, what do I have to go into, Mike?
There we go. There's that. And then.
Well,
Okay.
if your shirt's correct.
Yeah,
do you
your
see it?
shirt
Okay.
is correct, but
Settings.
if you look at your TV, you're saying you look at your TV and your TV is correct when you look at it?
No, it's not. Hang on, wait.
Yeah.
Let me change it for you guys. Oh, what did I press?
And signing off.
See you next month.
I totally got yelled at for talking during the outro, and Lisa did it, and it wasn't my fault, and I can't get yelled at for it anymore.
I'm sorry.
I got yelled at as well.
Everyone's yelling. I feel like I'm getting yelled at.
This is what happens when you talk during the outro. I roll you off the set.
Oh, burn.
No.
Look at she's crying.
Mike and Stoge both have a slight lag. So
Not that long.
hearing it. Oh, that was amazing, though.
Roll it back in.
It's literally just this show got yelled at.
Yay.
The exact same thing.
Oops.
Oh, that was amazing. That's the only thing I can do today.
For Pete's sake, people.
I would offer to edit it for
I
you,
can't hear.
except
I don't
I'm
have
not
ears.
physically in
I'm
the
sure
US.
she's making really good points right now.
Yeah, I know.
Just changed my
Whatever she
life.
said, she's probably right. Let's be fair.
She said she could edit it for you when she's not here.
No. Actually, editing the outro is hard because it's a dissolved transition with the existing audio from the show. So you have trying to delete that. It's actually fairly. It's not impossible, but it's a fairly complex edit to make it sound natural.
Yeah.
So anyhow.
They're saying it's like you kicked a puppy. I hope you got what you wanted.
But it is something I would do.
Oh, but everyone's really
say
supportive by Lisa.
another-
Poor Stoge.
I want to say another really big thank you to Dr. Braga for coming on and
Yes.
taking all that time out of your Saturday to come and be on our show. We really, really appreciate it. And the chat room was just exploding with questions. It was amazing.
Yeah.
Everybody was so engaged and interested in all of this new science. So really appreciate that.
I think I will be one of your friends.
Hey, say hi.
We want to be your friend.
Here, we can move over soon.
I want to be your
She's right behind
friend
you.
and have my name. Just kidding. You don't have to have my name there. Just be your friend because it's a very interesting show. Actually, at the Saturdays, I used to do that. Now I'm working too much. But I used to see these kind of shows.
Aw.
Thank you.
Very interesting. Thank you. Thank you for your work. Thank you for inviting me. So, bye-bye. Shall I say goodbye? Did it finish?
It's up to you. We're in something
Or
called
do
After
we
Dark.
have more?
You can chill with us.
Yeah, totally
We're
up to you.
finished. We're in a portion of the show that we call After Dark. It's very casual. It's very informal. It's kind of like an after show. So, I mean, if you would like, you can stick around. We just talk about anything now. It doesn't have to be about science.
Oh, you talk about everything? Okay.
Everything.
No
and
holds barred.
anything.
So what do you talk after dark? That sounds
There are
Should
some
with
more
like
questions. There are some
Lights out of nowhere.
There are some more questions that we didn't get a chance to get to in the interview. I
Yes.
mean, if you wanted to try and answer those, if you like. Otherwise, we can talk about other things like Disneyland or something.
Yeah, just off the top of your head.
Okay.
It's a universal topic. Let's see. You're a boo. Go kick a puppy. So, Doctor, someone on the chat room was asking about a previous interview you did with the glass batteries. Was that you? And so they were.
I think so.
Yeah, they were worried. They were not worried. They were wanting to know more, and if you've made if this is related to that, or if this is a new research path.
No. It is related. The electrolyte, the glass electrolyte, is actually the one that has dipoles and ions.
Okay.
Besides the ions.
Gotcha.
So we are also progressing, of course, in the research and trying to learn new things about it. So we are now more sure that. Or that one of the important parts is these dipole, this high dielectric constant, which is due to dipoles, like these molecules, very similar to water, but instead of having H2O, we would have lithium 2O and sodium 2O, for example. So these allow us to make other kinds of batteries, more than the fact that it is a glass. These would be more important characteristic. That's why I didn't really focus on the that it's a glass.
Okay.
And I'm sorry.
Not at all. Thanks for clarifying.
I have a question.
And in the front row.
So you mentioned that lithium-ion batteries have basically maxed out. So if we move to solid-state batteries, that means you're saying that we can continue to increase energy density. Is that correct? We can move beyond. So as you increase energy density, when you have a catastrophic failure, obviously that's bad because the battery is going to release its energy very quickly. Bad, right? So is there ways to make it safer? You're packing all that energy into a small space. How do we make them safe so they don't start fires and blow things up? And do you have any ideas about that?
That's a very good question, actually. I'm not saying that all the solid-state batteries would have double or in capacity. The double in capacity comes from these other properties, the fact that besides a battery, it is a capacitor, or it can store electrostatic energy as in a capacitor. So it's kind of a two-in-one, as you might say. So, and in our case, we don't have the same problems or catastrophic problems, because what makes the catastrophic problems in a lithium ion is the fact that you have a flammable liquid. In a solid, with a solid, you don't know, solid is not flammable. The solids in any solid battery, they are not flammable. So, and also they prevent the formation of these dendrites, these branches, this imagery that we have seen. Because if the solid wets well, wets is not like water, but if it sticks to the surface and it, instead of making a bubble, this is when it doesn't wet well, it makes a bubble. So this means that it's more that the ions are or the metal is more attached to the other atoms of the metal than to the electrolyte. In our case, it doesn't. The electrolyte doesn't make the metal doesn't make a bubble with the electrolyte. So it wets very well the electrolyte. This means that the growing of the metal when you charge, because the metal grows. We have electrodes of metal. They grow when you charge, but they grow in just one dimension, not in 3 dimensions with branches. So if you don't form these branches, and you just form another layer of material, there are no short circuits as well. So you eliminate not only the fact that you don't have a flammable liquid, but you also don't have the formation of these shorts, these short circuits.
So what
Plus,
you're saying, are they inherently safer? Inherently safer is what you're saying?
They are inherently safer.
Okay.
Plus, in these solid electrolytes where you have dipoles, you actually need the energy from room temperature to align the dipoles, because you have spontaneous polarization like in a ferroelectric material. So the energy from around you or room temperature actually helps aligning these dipoles. So it is used in that sense. So these batteries can work very well at 70 degrees or 100 or even 180 degrees C.
Okay, cool. All right, thank you. That was a good answer.
Very
Very
well.
thorough answer.
Okay. Anyone else have anything they would love to talk about?
In general?
Yes.
Where do I begin?
At the beginning, and when you come to the end, stop.
Actually, no, I'm just kidding. I'm never that exciting.
Lies.
It was very interesting, your intervention about the magnetic field. So it's actually not going to flip, or are we just, the magnetic field is only going to flip in some...
Right. The main point of the story was that because they can do paleomagnetism, which I didn't really explain how that works, that's actually very intensive field work. They have to go out into the field, and they have to rocks,
I have done that.
Yeah, it's
cut,
very
cut cylinders,
yeah.
cylinders
and they have to make a map.
In the mountains.
And they have to make a map of, and they have to of course fill in the blanks, because you could do one here, you do one here, and you got to put a curve, in your okay. So by the time they're doing all that, and you got to date the rock. So you're saying, okay, 49,000 years ago, the field was doing this, and they look at that, and they're comparing it to what's happening now, and they're like, well, that looks very. We know, because they know geologically, like I mentioned, when you're looking at the rocks and with the Mid-Atlantic Ridge, for example, you've got the stripes coming out, you've got reversals. So they date these. So now they have charts of this is when a reverse happened. They can go back and look and say, well, back in this time, we didn't have a reversal. And even though the magnetic field was doing this back then, similar to today, it didn't reverse. So we're learning more about how the fields actually behave. So that's the whole point of the story, is that we don't need to be so worried about a reversal, because initially, this is new science. It's only been around for 50 years. Going back 50 years, there was debate as to whether the magnetic field even flipped at all. American scientists especially were very much against plate tectonics. They thought Wegener, the guy who came up with it, was crazy. They thought he was a nut job. Continents can't move. They're made out of rocks. How can rocks move? That's nuts. So then when they first started scanning the ocean floor and making these maps, they were like, look at all these stripes now we have all this data. So now we're going back into the field and making paleomagnetic maps where this is what the field looked like 49,000 years ago and whatever. It's really crazy. Now we can start looking at the history of the magnetic field. And so that's like, the science is advancing even farther now, past just the basic point of just knowing, well, it could flip and dealing with that. So now we're learning details about, okay, how does it exactly flip? What does it look like when it's going to flip? So what I mentioned is you have a flip, which it actually does completely go around, or you have an excursion where it starts to get all crazy. It starts actually in an excursion. You don't even have a north or a south, a well-defined north or south. It can just start. Everything just goes. If that ever happened, that would be really kind of scary, because like
that would be even worse than a flip.
Yeah, you wouldn't have a magnetic north anymore. It would just be kind of this way or that way, and then it kind of then it goes back again. And how long does that last? I'm not sure. I didn't see that in the article, how long those excursions lasted. Probably, I'm sure on geologic time, it could last 1,000 years. I mean, that would be really crazy not to have a magnetic north for 1,000 years. Like, oh my goodness, what do we do, know?
And just like looking in the past few centuries, haven't they been able to connect like these crazy, not quite cataclysmic, but just these catastrophic weather events to like activity with our magnetic field and like just different, not necessarily switching maybe, but just like...
I don't know about magnetic, I don't know how much the magnetic field affects the weather.
Oh, it does quite a bit, yeah. Like especially when it comes to I believe it was almost like a mini contemporary ice age in the I want to say it was either the late 1800s or the early 1900s.
Right, the mini ice age. Yeah, I know what you're talking about.
They were
Was that
able
linked to?
Yeah, they were able to kind of make a connection between. I think maybe I might be misremembering, but if I believe it, or was it?
Because that short a time ago, the rocks from that period, when they'd be basically the peaks of the Mid-Atlantic Ridge right now, so. Or would they be clearly delineated? This is what was happening precisely.
I don't think so. I think it was more it was just kind of there could be a connection.
Okay.
And then so when they extrapolated that to far, far beyond when we would be able to see such evidence, then they're oh, that could be a plausible explanation.
Okay. I have not heard
I think
of it.
you are right. I think it does affect the storms, the sun storms and so on.
Exactly. It had to do with interaction with solar activity. Yeah.
Yeah, I can see that. Yep.
Actually, I'm sorry. What were you going to say? I didn't want to interrupt you, Doctor.
No. The sunstorms really affect our life here as well.
Yeah.
So I think you are right. I have seen also these shows that talk about those sunstorms and how they affect the life here on Earth.
They definitely affect the power grid. But the excursions that you were talking about, David, they sounded very much like a planet-wide almost sunspot.
Yeah.
Because the solar storms are tangling of the magnetic field localized on the sun, but it sounds kind of reminiscent of that. It gets a tangled kind of situation here on Earth.
Yeah, I know
and
what you're talking about. Yeah,
snaps itself back into place.
Yeah, the sun, they tighten up and wind up, and then they just go,
Right.
That's right. Yeah.
Is that like magnetic recombination or something different?
What was that?
Sorry,
Is that like
whip this out.
magnetic recombination or is that a different process?
I think that might be a different process.
Okay.
Interesting. I need to strengthen my electromagnetic know-how.
Yes.
Don't we all?
Oh, this is kind of an interesting question. Sorry, but I got to ask one more battery question. What does a fail? Oh, so this is from TWKD. To Wicked. Sorry. My apologies to Wicked. Sorry, but I got to ask one more battery question. What does a failed solid battery look like? What is its version of magic blue smoke?
That's a good question. I think it's a battery which doesn't have that you charge and then you cannot extract any power or energy from it anymore. That's where they end. So here we just defined 80% of their initial charge or the initial capacity, and in this case they will after a few cycles. Most of the batteries will some of the solid batteries will not provide 80% of the initial capacity anymore. So that will not have any smoke. No, I'm sorry, no fantastic effects.
Okay.
No explosions.
That's great. No explosions. We don't want any explosions.
But sounds far less fantastic, or a lot more fantastic actually. But you just said that after just a few cycles, so right now solid state batteries don't have the rechargeability that lithium ions do?
No, not at all. We actually just published a paper where we show 23,000 cycles, which was very, very good.
Mm-hmm.
But this is not at all common in the solid state batteries because they don't have that capacitor part. This is mainly, we think, because of the capacitor characteristics and not because of the electrochemical characteristic as in a battery, more because it has the component of a capacitor. And we know the capacitors there are solid state capacitors. They were one of the first. And the capacitors can stand a lot of cycles, 100,000 and more. So that part in our batteries, I think we think, of course, this is research in progress, so we don't like to be very dogmatic about it, never. But we think that it's because of these capacitor part of our battery.
So it's just kind of greedy. It's holding on to that charge. After a certain point, it won't release it.
It's the problem with the solid state batteries is because the resistance in the electrolyte, the resistance to the diffusion of the ions through the electrolyte is very high. So a lot of energy is spent in that process of having the ions go from one electrode to the other. Plus, there are spurious reactions that occur at both electrodes. So at a certain time, these spurious reactions consume the ions that were free to move from one electrode to the other, and when they consume, they steal the capacity available, the initial capacity available in the cell, and that happens also in a lithium-ion cell, and that's why some the lithium-ion cells that in which you can that can go under 20,000 cycles. They are not charged to, for example, 4.3 volts. They are just charged to 2.5 volts or 3 volts, because they want to avoid these spurious reactions that happen with the electrolyte and the electrodes.
Okay.
So that you don't spend the ions in these reactions that need to be free to travel in the electrolyte to diffuse.
All right. That sounds very, so you don't charge lithium ions to full capacity so that you don't waste the energy to get that electricity back out, right?
You actually use other kind of electrodes in which you never need, you cannot even charge to high voltage. You just use electrodes that only charge to 2.5 volts, so that you don't charge to the window of your electrolyte. Let's imagine that your electrolyte has a window of 4.3 volts. So if you charge very close to these 4.3 volts, what happens is that electrons coming from your negative electrode will diffuse through the electrolyte and start reacting with the electrolyte. And this was exactly what I said in the beginning of our talk, that we don't want electrons to go through the electrolyte. We want them to go through the external circuit to provide the power to our computer or our car.
Okay, cool.
So that's why you use other electrodes that don't allow this type of charge to high voltage, so that you can. But that's always the secret. The secret is not to charge to higher voltages. If you keep a certain your battery at 80% or 60%, 70% of the maximum voltage it can charge, you avoid these spurious reactions that also happen if you hit your cell phone. So you should not have your cell phone in the heat, because these spurious reactions are going to occur.
Yeah, so I was actually going to ask about the 80%. So I know that JPL, that's one of the ways they've had opportunity last forever, is that they never discharge their batteries lower than 20%, and they never charge above 80%. So everyone, when on the tours, we would tell people that, oh, yeah, they run on lithium ions just like in your phone. And they're like, but they've lasted 13 years. Oh, my God. Yeah. So we have it from an expert. Don't overcharge your phone.
I know.
Yeah.
Jeez.
Well, of
right?
course, we should have BMS, which are the battery management systems that should help us not to overcharge the cell phone. They actually do that. The cell phone or the car or the batteries in the car. These are the most complicated and expensive part of the battery because they have to control a lot of cells especially in these cars, these EV cars. So and they have to avoid thermal runaway. So that's not only you avoid an accident, but also you keep your cells, your batteries with for a longer time.
Excellent. All right, we do have another question from Sarge Enzyme. How heavy are these solid-state batteries compared to lithium-ion?
That's a very good question. In our case, the density of our electrolyte is very similar to the density of the organic liquid with the salt, plus the separator, because it has to have a separator. So it's, you just, in the case of the lithium ions, you have to have the separator and the electrolyte with the salt, the organic solvent with the salt. So the density is comparable. So they would not be heavier than the lithium ion cells. And plus, if they can store more in less volume, then you can make. You can make them smaller.
You definitely pitch it that way. We're making the amount of electricity that you can carry smaller. Or I should say, we're making more electricity in a smaller package.
Or the same size, but with more
bang for your buck.
All right. Cool. Okay.
Yeah. That was a good one.
So, looks like we are done. I don't know how to sign off from After Dark. I'm going to say thank you for joining us.
You don't really have to sign off right After Dark. You just tell them,
Deuces.
we leave.
Bye-bye.
Go home.
Bye-bye.
Bye-bye.
Bye-bye. You can't stay